in this example, I wanted to play with the idea that you wanted an LLM to be able to answer a question, but not from content that exists already, like from books or websites, but from data, maybe telemetry data, maybe data that's in a database, where you don't have necessarily written content, you just have these data points. And there's a whole slew of our lives that revolve around monitoring things, observability, or we have databases. And there's also databases out there where you may have somebody who you need to be able to query a database, but they don't know SQL. But it would be better if they could ask a question and then we could sort of query the data that way. So in this video, I'm going to show you how we could leverage an LLM to generate SQL code that we could then execute to get back data from a question in English, and then take that data and wrap it around another prompt where the LLM could provide an answer to that query where there's no SQL or anything sort of involved from the user. Pretty cool little exercise. Now, these types of sort of AI systems require very specific knowledge of the data you're working with. Less, again, is more. We're going to play with a system where we've got 3 tables, though I think I would recommend trying to do this with just 1 table of data. But I wanted to play with joins and things like that. The more generalized your data is, I think the more difficult this becomes. But you'll see sort of what I've done here, and you can run this at home. So this exercise will require us to be able to run OLAMA. We're going to run a Postgres database for our data. We're going to use a relational database. We don't need to do anything with vectorizing here because it's not about doing a vector search. It's about doing a database query. And we'll see if we can write enough code here to kind of get the system to feel like it's working. So the first thing that we really need to do is we need to have a table schema and some sort of data to play with. So under examples number 8, I have a couple of folders here with our main.go. First folder is some prompts that I've played with, and the second folder is for the SQL. Now, this is going to be the schema of our data. Again, I think it's nice to just have one data table for these things, but I wanted to play with joins. And these tables come from my Ultimate Software Design class. You see we've got a table of users, we've got a table of products, and there's a foreign key between products and user. And then we've got a table of homes, and again, we've got that foreign key. So there are users have products. This was a garage sale system, and then there are homes that you're selling these products in. We've got this table schema. Now, I wrote a little Go code that can sort of migrate our database into this table, but I needed some sample data in order to play with. And I thought at first, what if I could get the LLM to sort of generate the basically these SQL statements here. I didn't want to do this by hand. I don't know how many times you've worked in a relational database or a database and you needed some sample data, and to be able to try to produce this data was sort of tedious. And so I think the first step was, can we get an LLM to sort of produce this? And I'm going to show you this now and how we do that. Now, in order for this exercise to run, we need a couple of things running. I need OLAMA running because I'm using OLAMA, and we're going to use the Llama 3.2 model. The Llama 3.2 model is really good at generating code and doing chat. So I'm running the OLAMA model here in this window. I also needed a SQL server. We're going to use Postgres, I think version 16.4, and I'm going to bring that up using Docker Compose. I'm also going to bring up Open Web UI in Docker Compose so we can play with some prompts to see how things are sort of working. So even though you see Mongo up here, we're going to have our Postgres database running. In fact, I can double check that it is running by connecting over here with my PG CLI tool. So I've got a Postgres database running leveraging the Docker Compose. I've got OLAMA running natively. It's just faster that way than running it in Docker. And thanks also to my Docker Compose, I've got the open web. Actually, it runs on localhost 3000, sorry. There we go, 3000. And we're going to play a little bit here using this chat tool with the Llama 3.2 model. Beautiful. So real quick, because I should have shown you this and I didn't, Docker Compose. So you can see when I said compose up, I started Postgres. We don't need the Mongo in this example here. I like running OLAMA locally only because it runs slower inside of Docker. And we're using the open web UI to play with, all right? And if I go to the make file and I go to OLAMA up, you can see here how I'm running. I like to keep all of the files related to databases and OLAMA sort of locally here in the project. So we've got everything running. And like I said, I didn't want to do these insert statements sort of manually. So I came up with this prompt here that I wanted to play with and show you here locally. So, and this is basic structure we'll use with Llama 3.2 when we want it to generate SQL code. So we give it a set of instructions. We're going to tell it from an input perspective what our table structure looks like. We're going to share with it information about joins. Now this one doesn't belong here because I don't really have that table. I forgot to get rid of it, so we'll get rid of it. So we're sharing how these tables join with each other. And this initial prompt I found online somewhere and tweaked it, and it works really nice with the Llama 3.2. Then I'm telling it to just generate some SQL insert statements and then given a question here. Now, again, if you've watched the other videos, I've tried to share with you, ask the LLMs, ask these models to do one thing at a time. If you ask it too much, it's not going to work. And so what I'm going to do is ask it to do this one thing right now. Just create an insert statement with proper data fields to create 5 new users. 5 new users based on that schema and these instructions. So let's drop this here and send this prompt to Llama. And look how good Llama 3.2 is in generating sort of SQL. Now, I don't like that it didn't give me proper UUIDs here. So what I might do is just run this again. And this is where we start getting into like consistency. This time I ran it, what did it do? It gave me something a little bit better to work with, right? And so I ran this prompt. I also ran the prompt. So what do we do next, right? We've got 5 new users. So boom, I put those 5 new users sort of right here into my insert SQL. And now I needed to produce some products, right? So what I did next is, I'll just do this, is now that I have this and I'm already in the chat, I don't have to run an entire prompt over again. I could, but what we could do is imagine this was the insert statement, okay? So what I'll do now is, in fact, I shouldn't, only because the chat history goes with it. So now I should be able to ask it this question. And now I've got products being generated. Now, again, instead of me asking it to produce 5 products for all 5 users in one shot, which it will have a hard time doing, and since I only have 5 users, it's just easier if I just ask it 5 times to produce users for each one of these individually. And within no time at all, the best part here is that I ended up with a file within about 5 minutes that we could use to insert data into our database. Now that I have the ability to insert data into the database, and I used my LLM to produce all this data within like 5 minutes, we've got that. The next step in our goal here is to get this data sort of inserted into the database. Now, I'm going to show you the Go code that I have there for that, but I could say select star from users, and you can see I've got this data already in the database. If I go to my main.go, right, and this is something that you can run, One of the very first things that we're going to do in this code base is the DB init. Now, what DB init's doing is it's taking, where is DB init? Let's get response. Here it is, DB init. All right, we're just going to embed the two files, schema and insert, and we're going to just execute those things every time we run the program. And we've set up these sequels, so do nothing if there's a conflict. No big deal. If not exists, do it. So we've got our first part done, which is we've got a schema. We've got it loaded in a database. We've got sample data. We've got that loaded in the database. And we were able to do that all fairly quickly, leveraging the LLaMA 3.2 model. Again, instead of asking you to do it all at once, we're just little pieces at a time. Okay. Now, remember what the goal is here. The goal is for a user to ask a question related to the data that is being stored in this schema, where we've got users, products, and homes. And the first part of being able to do that is getting the LLM to generate a query related to the question. Now, here are some of the questions that I want to be able to work with. This is a fun one. Find me all the users who have a home in the state of California. That is a question that should be able to be answered because we have users, we've got homes, and a user belongs to a home, which belongs to a state. Same thing. What are the total costs of all products for this particular user? That's another good question. And you see these few questions that I have here are questions that are relevant to the data. And I am using names related to the name of the tables and the fields, and I think that's fair right now. But you can see that these are questions that we should be able to answer. But in order to answer these questions, we need a SQL statement that can generate the data first. And that requires another prompt. Now, I've played for a couple of hours to find a prompt that I felt was working and consistent enough, and sort of landed on this. Again, finding things online and tweaking this as we go. So look at this prompt here that we'll play with a couple of questions to help generate a SQL statement, again, using LLaMA 3.2. Your task is to convert a question into a SQL statement, given a Postgres database schema. Adhere to these rules. You can read those rules. Then an input section that again shows the schema like I showed you before. There it is, same schema with the same sort of understanding of how these tables can be joined. Now this was the most important part of this prompt. Because there are similar fields in the different tables, we're going to need to understand which data belongs to actually which field related to each table. That was a little tricky. So I gave the prompt, or the LLMs, sort of like a template on how I wanted to join, when it's joining tables, how to do that. In other words, I explained that if you're going to be selecting user ID, I want the name to be like this, prefixed with users, or prefixed, in this case, with products or homes, and gave it the basic template for a join. There's no where clause there. And again, because these LLMs do autocomplete, it should be able to leverage this and be able to then know that if it's going to be putting users.user ID, this should come next, right? That's going to be that power of the LLM and the autocomplete. And also be aware, like one of the first rules that I have up here is how to use the table name and the field, or the column in this case, to do the join. Okay. And then we can ask the question. So this is a cool prompt. Now, why don't we try this prompt again in our open web UI? So I'm going to basically, the fastest way to do that is, let's take this question here. And I'm going to just put it here as if we were doing it by code. And I'm going to take all of this, and I'm going to go into the open web again, start a brand new chat so there's no history, and see if we can generate SQL related to that question. So pretty good here, right? It generated a SQL statement. Funny that it added some counts from users, join. It leveraged that sort of, I'm making it a little bit bigger for you there, home state and with a group. Now, let's just see if this isn't the query that I expected to get back. But when I was playing with this, what I would do is take the select statement, go back to my PG-CLI prompt, see what would happen. Now, this actually produced good query. It was a good query with all the right answers. Elena and Sophia, they're both from California. And so this query ended up being good. It generated it. And it generated it with a group by and all of that. Now, watch this. Let's take the same. I'll do it this way instead. Let's do it again. Come back into our code here. See if it generates the same SQL. Now, this is a lot different. Now, what's funny about the coalescence here is I do try to tell it not to use that function. Now, I like the where clause. I like the from. I like the join. The select looks sort of complicated. Let's see if it actually produced proper SQL. It did. And this time I got more information back, but I got the 2 usernames again. So in all these different cases, this prompt is, for our purposes, it's working, right? Even though the LLM is changing the query up a little bit, it's working. Now, one of the things that's interesting in the change is maybe some of these settings. There is these defaults related to like top P, which changes how things are, how random you want things, or how you want things to change, right? So maybe when we're generating SQL, we want this to be a little less entropy, right, or change in that. I have to look what we're using on the Go side. But you can see it's set to 0, which I think would mean, you know, don't try to be creative, in other words. And when we're generating SQL, I would imagine that's what we want. But either way, look at what we've got. We're getting answers here. We're getting proper SQL. It's still based on our template. So I feel like this prompt is working. It took me a long time to get to this prompt, but maybe as an exercise, you could try to tweak the prompt and get it to be more consistent, maybe better. Okay, so we've got a prompt now that's working, right? Let me undo the changes that we made here. Now I want to do this in Go code. I want to use this prompt and take the question and then be able to get to that same sort of query. And then I want to execute that query and get to the data. So let's take a look at more Go code now and how we can do that. So we've initialized our database. We've got our schema in there. We've inserted all that data. I'm then going to ask the user for a question. We're going to use our, this Go standard library for that. I say, give me a second. And then what we're going to do is make an LLM call to get that query. And then here, we're going to just put the query in there. I'm going to comment out the rest of this code until we're ready to use it. And right now, I just want to be able to execute the prompt against the LLM to get a query and display the query. Now, here's the code that we need to do that. We're going to say, okay, OLAMA, which is part of the LangChain Go repo with model. We're going to bring the question into our query prompt, right? I'm using the embedding for that. And then I'm going to make the LLM call. Now, I'm not using any options. We're using the default for the top P and all that other stuff. And then we'll get a result and we'll pass it back. So again, thanks to LangChain Go, this is all fairly simple to talk to OLAMA. But let's see what happens now. We did hand test it using Open Web UI, so I don't expect this to be sort of any different. So let's come in here. Let's do a make example 8. There it is. I'll come back to our question. We'll play with this question here. Find me all the users who live in the state of California. And we're just making a call to the LLM. And here's the query that was produced. It's a much simpler query too, right? And it is following the example that we gave it for using as to give us unique field names for all of this, right? So you sort of see that. Nice. And this is a query that we can execute. We know this query would work. If you're familiar with SQL, it feels like a good query, and it was. Okay, great. Now what we need to do is execute that query to get the data back. Okay, that's not a problem. We're going to do that right here. Now, I have added to my project in the foundation layer a SQL DB package that I use in the ultimate software design for that service class. We're not going to go through that. You can see it. The key is you can use any sort of mechanic or package you use today to execute SQL against Postgres. This is the one that I have. But I did add a special function to it called query map. And the idea is that I want to get the data back raw. I just need to know the sort of column name and the value that comes back from the query, right? So I just need to know that this was user's ID and what the value is, user's department and what the value is. I have to keep it raw because the query can bring back different data. So I found a way to do that by using a map. And it's a slice of maps because there's multiple records that come back, which is exactly what we're going to get here. We're going to get 2 records back. Then I need a slice of each record. So essentially, we're going to generalize the record in a map, and we can have a slice of those. And my little query map function in SQL DB package does that. And you can look at that code on your own. So now when I do this, we should not just see the query, we should also see the results. And I decided to put those results in a key value sort of pair. Okay, so let's run this again. And I'm going to go back to the question. There it is. And this time we got the query. Beautiful. Very same query. And now you can see the results that I just put it out on the board, on the terminal. So I've got a key and a value, result 1, result 2. And you can see thanks to that as template, we know exactly what table and field that is coming from. So we see we've got Sophia, we've got Elena. So we've done the first part. Right? We have a prompt that can generate SQL in a way that gives us representation of the data in a key value pair, and we have all the results. Now what we need to do is take this question and the data, right? Normally this data would come maybe from a vector search because we had content that we vectorized and it was similar. We don't have this. This time this data came out of the database, but we use the LLM to figure out what the data is as opposed to some sort of vector search, right? This is a SQL query. And now what we're going to do is find a way to take this data and get it to work in a prompt. So I'm going to take this result here. I'm going to pull it out of my terminal, and I'm going to get to the response. Now this prompt is really small, isn't it? Your task is to look at the data results and provide a complete answer to the question. Adhere to these rules. Don't explain your answer. Do not provide the raw data. Then we're going to take that data that I produced and stick it in here, just like this. This format seemed to work great. I didn't play with other formats because this format worked, but that's something that maybe you want to do. And then we have to give it the same question. We'll give it the same question. Now, this last thing here was important. Even if you don't see information about the subject in the question, the data is related to the subject. If I don't add that, then the model kept telling me that the data wasn't in line with the question. Like there was a mismatch, like I'm asking for something, but it's not there. So that last sentence was critical to getting this prompt to work. Play on your own without that, and we'll see what happens. But now that I have this, let's take it. Let's go back to our chat app here, put it in there. And you could see that the LLM was able to pull out just Sophia and Elena's name off of this sort of data set. Pretty cool, right? Okay, let's put this prompt back the way it was. And let's bring this last piece back into Go by essentially now making another call to the LLM using the response prompt. So if I come up here, oh, there it is right there. By calling get response with the same question and the data that we got back, and the data being in this slice of maps. So we go to get response. Again, just getting a connection to OLAMA. I'm building out the data just like you saw it displayed before. I'm using sprintf to bring it into that prompt, and then it's just another LLM call. So not a lot of Go code to make all this sort of happen. The real magic is in figuring out the prompts and making those prompts work. So now we should be able to run the whole thing. There it is. We run example 8. We ask it for a question. It generates the query. It generates the data. Now this is interesting because this has happened to me a couple times before. Instead of just giving me the name, it's given me a SQL statement, right? Like I've seen this happen the last few times. So what does that tell me? Like maybe I need to say, do not provide any SQL code for the answer. Maybe I need to add this sort of to the prompt so it won't do that again. So let's run it again. Example 8, find me all the users who have home in California. Boom, beautiful, right? Sophia Sanchez and Elena Vasquez. It answered the question. Now, maybe we can play with this prompt a little bit more so it gives me a more sort of fluid answer. I've played with that. I haven't had a lot of luck. Maybe you will, and then you can share that with me. But let's try one of the other questions, which was also interesting, like this one. And I'll show you why that last sentence is important. What was the name of the last product user Rodriguez entered into the system? All right, let's run that and see what happens here. So smartwatch is the right answer. Let's take this query that was produced. We could see that it came back as smartwatch. That's kind of cool. We can also see that it has name and smartwatch there. And the question was, what was the name of the last product that Lewis entered into the system? So that was pretty good. I mean, that was really good. How about this one? What was the total number of unique products for each user? Provide the username and count of the products. Let's see if this question is still working. And these are different questions related to the same data. I must have an enter there somewhere. So I'm going to, the way my prompts work, just do that. Let's do it again. Even though I feel like it worked, I didn't get to see it. Interesting here. So here's the query. Here's the 5 data results and the number of products that they have. And there's the name and the product count. So again, the Llama 3.2 was able to answer this question, and we got those answers. What about this one? What is the total cost of all products that Lewis... Again, it took a while to come up with a prompt that would do this. Now, do you see the answer here? Total cost of all products for Lewis is $48.49, which is the right answer. Watch this for a second. I'm going to get rid of that one line in the prompt. I'm going to ask the question again. And it worked this time. I was experiencing before that if I didn't have this last sentence, sometimes it would say that like Lewis wasn't part of the answer, so we didn't know what Lewis was doing. And again, this is sort of part of you tweaking the prompts to do this. So that's the only query that I haven't run. I should do this for consistency. I just did this so I have different questions. Let's at least run this one. So all of these questions I got working with the prompt that we have here. Oh, finally, look at what happened here. We got a piece of SQL that doesn't work. It hallucinated here, right? But let's ask it again. And now we got to spend a little more time sort of tweaking. So suddenly I have a question What was the date and time the user Lewis entered the smartwatch into the system? If we go back and look at the schema, right, for products, there is a date created and a date updated. So maybe right now, okay, what was the date? What if I just say date for a second? And these are the little things that you're going to have to do over time to tweak. I can't tweak the question, but I can tweak the prompt. Here's a perfect thing. There is no information about a user named Lewis or a smartwatch in the previous data. So this question is suddenly not working for me with the prompt that I have, right? And so in a system like this is a good example. I still have some more work to do with this prompt to get it to work with this particular question. And that's great. Now I've got something to do after our sort of lesson here. I'm glad that happens, and I'm going to push this, and you'll have it too to play with. And so I think for this exercise here, it's a great example of something that you can play with here. Main.go, again, tells you everything you have to do to get up and running. But what I love about this exercise is it shows you that your data doesn't always live in some sort of content form. It doesn't come from a book, doesn't come from a website. It's coming from a database, and you need a way to extract that out of the database. And using one of these coding models like Llama 3.2 to generate SQL is an interesting sort of way to do it. It's going to take time for you to tweak prompts, to give prompts enough examples so it has enough to auto-complete in the right direction. I've sort of given you a start for that here, and this is a cool little sort of example to continue to play with. And if you can find ways of tweaking the prompt to answer that last question and make it better, share that with me so we can share it with others that are sort of working on these things, especially those working on them in Go. So I hope this new example where we're leveraging coding models and SQL execution and then prompts to formulate answers was super interesting.